Let's do a couple more of these together. Ken solves an expression using properties of exponents and gets 3,125 x to the 20th, y to the 15th as a simplified expression. Those are some big numbers. Which expression, when simplified, will give the same answer? Select all that apply. So now we've got to look and go through all of these. Well, starting off with letter A, we've got our product rule here, where we need to distribute in our exponent here. So that's going to result in 5 to the 5th times x to the 4th times the 5th times y to the 3rd, or 3 times 5, which, once we actually do this multiplication, we'll get 5 to the 5th, x to the 20, and y to the 15, and 5 to the 5th is 3,125. So this one is equivalent here. So A checks out. Now let's look at letter B. So again, we want to distribute in our exponent of 2, and we'll get 5 squared, x to the 4 times 2, y to the 3 times 2, plus 5 to the 3rd, x to the 4 times 3, and y to the 3 times 3. Now this one, I can see our exponents already aren't going to be high enough here. We got x to the 3rd, 5 to the 3rd, x to the 8th, y to the 6th, plus 5 to the 3rd, x to the 12th, y to the 9th. So what they're trying to do here is trick us into thinking that we can simply just add our powers together for our x, for our 12 and our 8 for our x's, giving us 20, and our 6 and 9 for our y's to give us 15. But that is not the case here, because these are being added together and not multiplied. So B does not check out. I'll switch colors from now on to keep these a little more clear. Let's try letter C. With C, we get, this one looks a little bit better to me already. We've got 5 squared times x to the 4 times 2, y to the 3 times 2, and this is, I'm going to leave it in parentheses now, all being multiplied by 5 to the 3rd, x to the 4 times 3, and y to the 3 times 3, which is going to give us 5 squared, x to the 8th, y to the 6th, times 5 to the 3rd, x to the 12th, and y to the 9th. And now, this time around, we have all of our terms being multiplied together, so we can use our product rule here and add our exponents together. And that's going to give us our 5 to the 2 plus 3 is 5, x to the 20th power, 8 plus 12 is 20, and y to the 6 plus 5 is 15. And like I already said, 5 to the 5th is equivalent to 3,125. So we are good to go here with C. C checks out. All right, now with D, we've got a whole string of terms being multiplied together, which just means we're going to be repeating our product rule over and over and over again. So in this case, it's going to be easiest just to count our terms here. So if I'm looking at our bases individually, we have 5 to the first powers, which is going to be 1 plus 1 plus 1 plus 1 plus 1, giving us 5 to the 5th. Now looking at our x terms here, we've got x to the 4 plus 4 plus 4. We've got 5 4s here. And then y, we've got similarly 5 3s, which is going to result again in 5 to the 5th, x to the 20th, y to the 15th. So D is good. D checks out. We're good to go with D. And with letter E, This is the same problem that we ran into with b. These are not being multiplied together, so we can't apply any of our rules. We don't need to take e any further from here. And we can simply just say, well, if we want to reduce this, we could just say this is equal to 25x to the fourth, y to the third. Because we have all of these like terms, we have 5x to the fourth, y to the third, and that's happening in groups of 5 4 more times, giving us a total of 25 groups of x to the fourth, y to the third, which isn't equivalent to what we were looking for, so letter E is incorrect here. All right, now let's take a look. An equation is shown below. A to the something power times b to the fifth power is equal to a times b all raised to the fifth power. And earlier we had discussed that when we had our exponent right on the outside of our parentheses here, we're going to want to distribute that into both of our terms, which is going to give us a to the fifth times b to the fifth. And that looks like we're missing a 5 here for our missing value if we have a to the fifth. So it looks like letter C is the right choice we want here. We have that missing value of 5. All right, let's do one last problem together. We've got an equation shown below. So we've got our variables here all being raised to the third power, and we need to figure out what's out front here. So it looks like they took care of our a and our b terms. We're just trying to figure out what happens with our 5. So if we're distributing that 3 to all of those, that means we should be getting a to the 8th, b to the 7th, all over 5 to the third power is equal to a to the 24, b over 21. And down here we had 1/5, so I'm going to bring out that 1/5 out front and say that should also get our power of 3 here, which if we have 1/5 to the third power, let's rewrite that over here and say that's equal to 1 to the third all over 5 to the third. And we've got our a and b terms. And that'll give us our final answer of 1 over 5 to the third is 125. Pen's dying on me, it looks like. We'll switch colors. 24, b to the 21. So it looks like we're missing 125 here for our missing term. And I would just like to point out, before we wrap up, one little nuance that it didn't come up in this lesson, but it might come up at some point for you later on in those keystones. So if we have two terms being multiplied together, like we had in the example right above this one, a and b to the fifth power, like I said, we're bringing in and distributing that exponent to each of these terms, which gives us our a to the fifth, b to the fifth. But had you seen something like a plus b to the fifth power, well, when we have any operation or either addition or subtraction inside here, we cannot distribute our exponent into these terms. It doesn't distribute over those operations. It's only when we have a product or a quotient inside here that we're bringing in our exponent to each individual term. So this does not equal a to the fifth plus b to the fifth. What this would actually mean is we're taking a plus b and multiplying the group a plus b, or the sum a plus b, 5 times. Which, if we actually were to do that, we would get something very different than a to the fifth plus b to the fifth. So that's just one thing I wanted to make clear before we wrap up. But that's all I wanted to cover for this lesson. So take care, everybody, and I will see you in our next lesson.